Welcome back at my channel. So in this video we are going to start the Laplace transform. So from the Laplace advanced differential equation. So what is the Laplace transform? Let's first write the definition. A function f of s is real valued function and differentiable then Laplace transform of is given by Laplace transform of f of s is given by 0 from 0 to infinity e to the power minus st f of t dt. This is the definition of the Laplace transform. Now this can be written as limit b tends to infinity integral 0 to b e to the power minus st f of t dt. This is two definitions are equal. So this is the definition of Laplace transform. Now let's look at some example of Laplace transform. Now piecewise, let's look at the piecewise continuous function. Piecewise continuous function. Please note down it conclusion that ft is continuous and differentiable function at closed interval a b such that where a and b is given by t1 less than t2 dot to t. And if ft is continuous and differentiable at each subinterval of AB, then ft is said to be piecewise continuous function. So please note down it next. So if you have noted down it next, we have to write the next definition. So we have write it. So let's explain what is have written. Now what I have written is, so if ft is continuous and b such that let if f is the function, this is the graph of f. So this is the point A, this is the point B. So let t1, t2, t2, t dot tn. So if there is a curve such that this is the continuous of function from this is the continuous. From this we can find that if there is a point, this is case happens. So we say that this is a continuous. That means every subinterval f is continuous, ft is continuous in subinterval, in each subinterval of a b. Then we say that it is a continuous. It means we can draw a graph like that. So that is the continuous definition. Now let's move the definition of exponential order. So please note down it. Come. Now let's move the definition of exponential. Let have some elementary application of Laplace transform. Now find a Laplace transform of f of 1 equal to 1. So what we have written? So we know let solution f of s is 1 and f of s is 1. So we know Laplace transform of f of s is nothing but 0 from 0 to infinity e to the power minus st f of s dt. So what we can write now, that can be written as limit b tends to infinity 0 say b e minus st from f of s. What we have 1, so 1 dt. So let limit b tends to 0 say b e to the power minus st dt. So what we can write from this integration, s is the constant, so e to the power minus st upon t. by s minus, there will be plus. From this there will be plus, because here we have a minus sign. Due to the, because of the limit it will be minus, and because of the minus it will be plus. There will be 1 by s. When we put the value t equal to 0, that will be q1. So taking the limit on this side, so s p tend to infinity, e minus s infinity plus s, that will be 1 by s. That will be 0, so there will be nothing left. So we get, note down it, Laplace transform of f of 1 s, 1 equal to क्या है 1, that means 1 by s, that is Laplace transform of 1 is what, 1 by s. Please note down it. Then we move to the further. From this result we are making the some elementary application that will come under the standard result of Laplace transform. Now let's move the further. Find a Laplace transform. To find a Laplace transform of x. Find the Laplace transform of f of s equal to, so f of t equal to t square. So what we have now, we know solution. Laplace transform of f of s, f of t equal to 0 from 0 to infinity e to the power minus st f of t dt. So what we have, ft, from the ft we have t square, that is from 0 to infinity e to the power minus st t square dt. When we integrate it, so that will be the e to the power minus st by minus s t square minus 2t e to the power minus st by, from this there will be plus s minus 2e to the power st, from this side that will be s, okay, from 0 to infinity, okay. Now you can put the value, then you can find it. Now let's move the sum. Please make a correction on function of, please note down. Let's, from this you can find it. Now function of some exponential, function of exponential order, let ft, if there exists a positive real number m, a number sigma and finite number t, a number sigma finite number t, such that for all t greater than equal to t naught, e to the power sigma t f of t less than m, then, or f of t less than m e to the power sigma t, then order of, then we say that ft is the function of exponential order as t tends to infinity, then order of ft equal to order of e to the power sigma t s tends to infinity, as यहाँ पे t tend to infinity. So now we can say that this is the order definition. Now show that ft is the exponential order of 2. Now for what is this mean, that we are now finding the order of a function that is which satisfies order of a function. Now, what is the order of exponential function? If function satisfies this condition, then we can satisfy the order of ft should be equal to the order of ATI. When t tend to infinity, what is the value we will get after t tend to infinity of a function? Then we can say this is the order of a function or function of a order n. Suppose like that. Now, find the order, or show that, write on it, show that the order of ft equal to t square is 3. Now what do we have? Now we get solution. What do we know? The order of a function is defined by that. Order of a function is defined by that. This is equal to less than equal to sum n. That means order of fm is less than equal to sum n. But we have now limit tends to infinity e to the power sigma t f of t. That means t tend to infinity f of t by a sigma t. That means ft will be what will be the value of ft? Ft will be t square upon a sigma t. That will give us, when t will be infinity, that will be 0. That is by L hospital theorem. What we get? That will be at t tends to infinity 2t upon a sigma t into t cancel, that is 2 by a sigma t tend to infinity, that gives us 0. That means what we get when we put the value t tend to infinity, we get the value 0. That means here the function is order 3. Now exponential order, what we get? This is the exponential order. Now let's move to the next question. Please note down it. Now show that ft equal to tn is exponential order as t tend to infinity. Now tn, what will be the value of tn? So now we have to show that this is the exponential order. So solution, what we write? In solution, what we write? We know exponential order is defined by when t tends to infinity e to the power sigma t upon ft. Okay, that means limit tends to infinity e to the power sigma t upon t to the power n. So we can write it limit at t tend to infinity t to the power n upon e to the power sigma t. What we get when t, that will be infinity by infinity form. So what we use? We use the L hospital theorem instead of, so we using the L hospital theorem, t n minus 1 upon e to the power sigma t into t. So what we get? N will be outside of the bracket, so t tend to infinity tn upon e to the power sigma t square. 1 minute. Sigma t into t square. Now we use the, instead of using, we will use the n minus 1, so that will be n t tend, when we put, that will be give us infinity by infinity. So n minus 1 t n minus 2 upon a sigma t plus t square a sigma t. Okay, now we can take it common outside, so n into n minus 1, so t n, when we put the value, that will be t infinity, so that will give us same value. So what we will get after repeated application? We get after repeated application, we will get, that will be nothing. There will be nothing in left get in case. So what will you get? In numerator we put this value, we get 0 after repeated application. So ft equal to tn is the exponential order of n. Now there is other some function that do not show the exponential order. So let's check the function. Show that f of t equal to e t squared do not show the exponential order. What we get? Now what we know? Limit t tends to infinity e to the power sigma t e t square. Now we are writing it directly. So e tend to infinity e t square upon e to the power sigma t. What will you get when we differentiate it by L hospital rule? T tend to infinity 2t e2 plus e sigma t into t will cancel. Okay, so t square. So what will you get? T et into et square. So et 2t cancel. Now we are now limit 10t tend to infinity et square minus when we put t tends to infinity, what will be the value? When we put the value t infinity, e infinity square minus sigma into infinity, that give us 2 into infinity, that is infinity. So that does not give the value. What is the condition? If this condition is satisfied, e to the power sigma infinity f of t less than m for some constant. Now here we get the value, that is the divergent, not convergent. That is the function is convergent, so that is divergent. So this is the divergent function. So this is not exponential order. So what we get? This is the case of exponential order. So for this video we have stopped here. For next video will come soon. So stay tuned by subscribing the channel of Salaman Majumdar on YouTube or follow me on Facebook. Thank you for watching me again.